Okay, so this is continuing on with our Unit 3, Day 2 notes on domain and range. And so what we're going to look at now is a continuous graph, and we're going to find our domain and range. The way we do this is we think about all of the possible x values if we want the domain. So I want to know what's the smallest x value I could possibly have, and I want to think, is it included? And then what's the biggest x value I could possibly have? So we're scanning our x-axis from left to right here. Okay, so if I'm on the left side, the smallest x I could possibly have, that's actually -4, -1, -2, -3, -4. That's the smallest x I can have, -4. Is it included? Well, that's an open circle, so no, it's not included. Okay, and then I want to know what's the greatest x value I can have. So I'm looking along the x-axis, and it looks like the biggest one I could have is a 4 here, +4. Is that one included? Yes, it's a closed circle. Okay, so I know that my x has to be somewhere in between the -4 and the +4. So sometimes you'll see people write it like this. These are my boundaries on the x-axis right here, -4 and +4. All right, so if I want to put that in set builder notation, I'm going to tell you all about domain. So that's my x's. It's x such that. I know x is in between -4 and 4. -4 and 4. X is in between. So -4 is less than x, just less than x because it's an open circle, but it's less than or equal to 4 because that's a closed circle. Okay, and so it's the set of information, so I use curly braces. All right, and so we're going to look at our y values also, our range. So if I consider my range, I'm going to do the y values from bottom to top, right, from least to greatest. So what's my least y value? Well, I'm looking along here. It looks like it's right here at -1. That's the smallest y value I can have. Is it included? Yes, that's a closed circle. And the greatest y value I can have, if I scroll on up here, I'm right here at 3. That's the biggest number I could have. And is this 3 included? It is not, because that's an open circle, so I say no. So if I want to think about my y boundaries, because that's what I'm going to tell you when I talk about range, I look, here's my smallest y. Oops, my pen doesn't work in the way I thought it would. My smallest y is right there, and my biggest y is right here. That works better. So those are my boundaries for y. Okay, so I'm going to tell you all of the information about y. Zoop, a little bit up. Y such that y is in between -4 and +4. That is so not right. Those are my x's. Y is in between -1 and +3. Sorry about that. Y is in between -1 and +3. See, this is my smallest y right here. This is my biggest y. Y is in between those guys, and it can equal -1. So -1 is less than or equal to y. But y is just less than 3, because that's an open circle. It can't be included. Okay, and I want that set of numbers, so I'm going to close my curly braces. All right, so example 7, we have another continuous graph. So when I look at this one, I'm imagining what's the smallest x value. Well, this could potentially go on forever, ever toward -infinity, right? So there's no smallest x value. So I'm going to say it goes all the way to -infinity in the small direction in the left. And is it included? No, it's not, because we never include infinity. What's the greatest x value? Well, this could also go on forever, ever to the right, or positive, so there's no real value, so I go all the way to infinity. And again, infinity is not included, so I say no, it's not included. Okay, so I have a couple ways that I can write this. It's any real number, right, in between -infinity and +infinity. So one way I can say it is x such that x is in between -infinity and +infinity. That's a way to write it. Or you can say it's any real number, right? Because it can be anything. So I could also say x such that x is an element of the real number system. All right, so when I'm thinking about my y's, my range, it's actually going to be the same. Y can go down forever, ever. So I'm going to be -infinity all the way up to +infinity. -infinity is the smallest y. We don't include it because it's infinity. And +infinity is the biggest y. And oh my goodness. All right, so our greatest y value goes all the way up to infinity, and because it's infinity, we don't include it. So we say no, it's not included. So if I want to represent the range in set builder notation, I'm telling you again, y such that y is in between negative infinity and positive infinity, right? Or I can say y such that y is an element of the real number system. Either one of those is fine. Also, if you tell me all real numbers, that's fine. That makes sense. All right. So example 8 is a little bit more exciting because on the x values, I can go forever to the left, I can go forever to the right. So my smallest x is negative infinity, and it is not included because we never include infinity. And positive infinity is the biggest, and it is not included. If I want to represent that domain, I'm just going to say that x is an element, x such that x is an element of the real number system. But you can write it either way. You can go back to your old example and use that other way. All right, my y values are more exciting though, because look, scanning from top to bottom or bottom to top, my smallest y value is negative 3. It is included. So if I have a graph, I have some sort of a line that is a solid line, I know it is including that value. Okay, so I'm going to say yes. The only reason that you would ever say that it's not included is if there was a very obvious open circle on your graph, which we are not going to give you. But this is a solid line, and so we assume that we include negative 3. What's the greatest y value? Well, you can see I'm going up forever, ever, ever, right? So there is no greatest. I get to go to positive infinity. And no, I don't include it because we don't include infinity. So if I want to represent the y's, the range, it's y such that y is greater than negative 3 or equal to, greater than or equal to negative 3. That's a way to show it. I could talk about infinity. I could really say that y is y such that I go from negative 3. I'm going to switch around because I've got negative 3 on the left. Is less than or equal to y, which is less than infinity. But we don't normally write that extra stuff. We don't normally write it all out like that. I normally just would write it as y is greater than or equal to negative 3, or negative 3 is less than or equal to y. Okay, and then if we look at example 9, we have even more boundaries. So the smallest x value, I'm going from left to right. Smallest x value is negative 2. It is not included because it's an open circle. And my biggest x value is 4. That one is included because it's a solid closed circle. All right, so I'm talking about domain, so I mean x such that I know x is in between those numbers, right? So I'm going to say negative 2 and 4. Those are my boundaries, and x is in between them. Negative 2 is just less than x, and x is less than or equal to 4. All right. What is the smallest y value? I'm scanning the y's from bottom to top. So look at this. This is my smallest y value right there at 1. Okay? That is not my smallest y value. I have smaller y values. Okay, so don't be fooled by that. Smallest y value is 1. It is included because remember, if there's a line, we include it. And then what is my greatest y value? I can go all the way up to, right there, 9. So I stop at 9. 9 has a closed circle, so it is included. Okay, if I want to represent my range in set builder notation, I'm telling you all about the y's such that y is in between 1 and 9. And now I want to figure out, is it included? Yes. So I get less than or equal to. Is it included? Yes. Less than or equal to. Okay. All right. And so looking at the classwork, we had time for classwork for one class period, but not the other. So if I want to find domain, again, I'm scanning left to right. And so this classwork says state the domain and range in set builder notation. Okay, my smallest x value is negative infinity and my biggest x value is positive infinity. So my domain I might write as negative infinity to infinity if I was thinking about interval notation, right? I might write it as x such that x is an element of the real number system. Okay, any real number works for x. Okay, my y's, however, my range, I can see that I am at -1, -2. -2 is less than or equal to whatever y I choose. That's the smallest value I can have, but y goes on forever, ever, ever, up, right? So I know -2 is less than or equal to y. If I want to put this in set builder, I'm going to tell you y such that -2 is less than or equal to y. Surely if you wrote this as y such that y is greater than or equal to -2, that's also true. I suppose I could have written domain and range there, sorry. Okay, so over here, we're going to look at this circle. What's the smallest x I could possibly have? -1, -2, -3. So I'm going to go ahead and start this up, set builder x, such that -3 is one boundary, and then whoomp, 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 +3 is the other boundary. X is in between those guys, right? So I can see that it's a solid line that was a continuous circle there, so I'm going to say that I include those values. My range is all of the y's such that, I'm going to look, 1, 2, 3, it was -1, -2, -3. My -3 is my smallest value. Y is in between -3 and +3. Okay, so since it is a continuous line, I will say that we are including those values. Okay, on this one, we go on forever, ever, ever in both directions. So my domain, x, is x such that x is an element of the real number system, or all real numbers. Okay, my y, I can see that I'm going on forever down, forever up, so I know same thing for y. Y such that y is an element of the real number system, or all real numbers. Okay, domain over here. My x is going to continue on to -infinity and +infinity. We're going to assume it just follows this pattern. Okay, so domain again is all real numbers, x such that x is an element of the real number system, or all real numbers. My range though, look at this, my smallest y is -3. So I'm talking about all the y's such that, here's my boundaries, -3, and then 1, 2, and 2. Those are my boundaries. Y has to be in between those guys. -3 and +2. It's a continuous graph, and so I assume it's included. Okay, domain here. My smallest x is -1. So I know x such that x has to be greater than or equal to -1. My range, there is no limit to what I can have for my range, so all y's. Y such that y is an element of the real number system, or you could say all real numbers. My domain over here, x can be anything, right? X such that x is an element of the real number system, or x such that x is, it's any of the real numbers. My range though, there's only one thing I can possibly have, -1, -2, -3, -4. That's all I can have, y such that y equals -4. No other options. Okay. And finally, for this guy, my domain, the only x I could possibly ever have is 2, right? So x such that x just equals 2. It's not a function, but it is a relation. But my range is anything. Any number could be used for y. So I'm going to say y such that y is an element of the real number system, or of course all real numbers. Infinite solutions for y. This one, domain, I'm going left to right forever, ever, ever. So x such that x is an element of the real number system. My y's go on forever, ever, ever. Y such that y is an element of the real number system. Okay, so a little bit more kind of review here. These are discrete points again, so is this graph a function? I'm giving myself a vertical line test. Boop, 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 boop. I only hit one dot each time with my vertical line, so I say yes, because it passed the vertical line test. The domain is all of my x's. -4, -1, 1, 2, 3. Okay, it has not said write it in set builder notation, but I'm going to go ahead and do that because I've been practicing. It is x such that x equals, sorry, I'm totally out of room. Let's do it neatly. X such that x equals -4 or -1 or 1 or 3. Okay, and we'll magically make that all disappear. Okay, so what is the range? That's all of my y values. So I know I want y such that y has to equal any of these options. So it looks like it's -2, -1, 0, 2. -2, -1, 0, and 2. Right? Is this table representing a function? I'm just looking at my x values. I have some repeats right here. -1 can go to 0 or 7, so no, it is not a function. The domain, though, they've given me all of my numbers. I know that I want x such that x equals, in numerical order, -2, -1, 4, 5. Don't repeat. What is my range? Those are my y values, so I want y such that y is equal to everything over there. -3, 0, 3, 5, 7. And I finally have a mapping diagram. So is this a function? Nope, it's not, because that 6 goes 2 different places, so no. What is the domain? Domain is x such that x equals 6 or 7 or 8. What is the range? It's y such that y equals -4 or 1 or 3 or 5. And again, I put those in numerical order. All right, there was homework in Math Space for Unit 3, Day 2 that you want to go ahead and complete.